Hello viewers, welcome to CEC lectures. Myself Dr. Preeti Jagwani. I am from Department of Computer Science, Aryabhat College, University of Delhi. So in our present series of database management system, we have gone through various and we can say a number of topics. And in this continuation, today's topic is about database system architectures. So when we talk about database system architectures, this topic actually deals with how and where to store the database, what data is to be stored and so on and so forth, how this data is to be accessed and various other subtopics we can say. So database system architectures, when we talk about, is greatly influenced by the underlying computer system on which it runs. So for example, I am talking about, let's say, a computer architecture which is supportive of parallel processing thing, or which is supportive of distribution as in totality, or it is kind of a network system. So which computer architecture we are going to host our database onto, the database system architecture will be greatly influenced or highly under the impression of that computer system on which it is running. So for example, I am talking about, let's say, networking. So in the scenario of networking says some of the computers or networking of computers allows some tasks to be executed on the server system and some tasks to be executed on the client system. So query always we can say fires through a client system, while a server system is always there to we can say serve that system, and that division of work has led to client server database system. So we can say that networking is actually the concept which is working behind this kind of division of work and which is giving a rise to client server database system. Going further, if we talk about, let's say, parallel processing system. So parallel processing system within a computer system always allows the activity to speed up. Now which activity here I am talking about? Definitely the database system, their access, their read, write, and all the activities which are related to the database systems will be definitely speeded up. Whenever we need a more faster response to the transaction, as well as more number of transactions per second, more throughput if we are looking for, then the solution could be these queries can be processed or the queries to the database can be executed in such a way that they should we can say taste the flavor of parallelism which is offered by the underlying computer system. And need for parallel query processing has led to the parallel database system. So we have seen two examples that need of the division of the work has led to the client server database system, and when we talk about need for the parallel query processing, that has led to the parallel database system. Along with that, if we talk about the third concept which we started with, is distributing the data across sites in an organization. That is, as the name indicates, distribution of data across the sites in an organization. This is going to, give rise the, database which is distributed in a form, and it is not, we can say, a centralized architecture. So distributing this data which belongs to the database across various sites in an organization is going to allow that data to reside where they are mostly needed, where they are frequently needed, but they can be still accessible from other sites and from other departments. So for example, let us talk about a university system, university database system, which is working in a distributed environment, and in distributed environment it is a very sensible idea to keep the data related to accounts on the host machine of the accounts section, and then we can keep the data related to the teachers to the on the host machine of the administration section, and so on and so forth. So this is actually the data which is readily required by those sections. So for example, accounts is looking for the data belonging to the account section, and the teachers database is mostly most frequently used by the administration section. So here what are we trying to do is we are going to make the data reside where they are generated or most needed. So but it's not like that account section is having the data of the account, so other sections cannot access it. Other sections are obviously allowed to access it, but it is hosted on the accounts machine, because that's the most, we can say, appropriate place for that from the point of view of, we can say, the need which is going to arise. Also we can have multiple copies of the database along these various sites, which allows large organization to continue their database operations even when one side is affected. Now one side is affected, maybe there could be various reasons. There could be some downtime in the hardware, or there could be a natural disaster or something of that sort. So even because of any of the reason, if one of the sites is along a large organization, within a large organization, if down because of any reason, then if we are keeping multiple copies of the database across the different sites, we can always access them, and it is not like that closing one site or closure of one site is going to affect the access of the database onto the other sites. This is what you called, we can say, geographically distributed database. Now this could be a geographically distributed database which is in a large organization, and the database is stored in a distributed manner on various geographical sites, or it could be an administratively distributed data which is spread across the multiple database system. So administratively distributed data, the example to this was the university database system, which I have just explained, and the distributed database systems can handle geographically multiple geographically distant we can say systems. So this distributed database system could be geographically distributed or could be administratively distributed. So on which type of systems they are going to be stored, they are going to be hosted on, that is going to give you the current give the rise to the current architecture. Or if we talk about parallel processing, so if there is a need for parallel query processing, then we need to have a parallel database system. Similarly, the networking of computers allows tasks to be executed, some specialized tasks to be executed on the server system, and some specialized tasks to be executed within the client system. So that's why whenever we talk about database system architecture, we always say that aspects of computer architecture, different aspects like networking, parallelism or distribution, they are the factors which are going to affect the database system architecture actually. Now when we talk about so here we have seen that what is it which is going to give rise to different kind of architectures. Now if we want to get into what are different type of architectures, so here we can say here we have 5 types of different architectures or different we can say database system architectures. One is the centralized and client server system. Another one is the server system architecture. Third one is the parallel systems. Fourth one is the distributed systems, and fifth one is the networks type. So I repeat, and this listing of database network architectures is also given in the list which is shown on the screen. So centralized and client server systems, then the second one is server system architectures, third one is parallel systems, fourth one is the distributed system, and fifth one is the network type. So these 5 are the types of database system architectures, and we will be covering them one by one. So first we will start with the first and the most simplest type of database system architecture, which is the centralized and the client server system. So, centralized, when we talk about this, essentially means that it is running on a single computer system and it is not interacting with any of the other computer systems. So, it is centralized within itself, or centralized to one particular computer system. So, here we can have a general purpose computer system in which there could be one CPU, or it could be a number of CPUs but within a computer system, and a number of device controllers that are connected through a common bus that provide access to the shared memory. So, now somewhat going into the concepts of computer system architecture, you all are aware that what actually a bus is. So, bus is kind of a pathway through which your address, data and signals are going from one place to another. So, here in a general purpose computer system, when we are talking about the centralized system, then in that situation, that general purpose computers are going to have it could be one CPU or it could be more than one CPUs, and there are number of device controllers that are connected to that CPU, and the connection between the device controllers and CPU is provided through a common bus, and this common bus is also providing access to the shared memory. Now, when I am talking about device controllers, let me mention it here that each and every device is having a kind of a drivers of a software which is going to kind of control that particular hardware, peripheral or device, and those are known as device controllers. So, this is the situation. Now, when we talk about the single user system, so single user system, as the name indicates, it could be a personal computer or it could be a workstation. Now, what workstation or personal computers I am talking about? It could be a desktop unit which is single user. Usually it is having one CPU. Now, this CPU can be of one core, or it could be a multi-core CPU also, and it is also having one or maybe two hard disk. But the operating system, the special part here is, or the specific part here about the single user system is, the operating system is going to support only one user. So, we have a desktop unit physically. If we talk about hardware, there could be a desktop unit which is usually having one CPU, it could have more than one hard disk, but the operating system is going to support only one user. So, this was actually the single user system. But when we talk about multi-user systems, so multi-user system says there could be there are multiple CPUs, there could be obviously high chances of having more disks, more memory obviously, but the operating system here is going to be multi-user. Previously in the single user system, I was specifically stressing upon the operating system is able to serve only one user, and here the operating system is able to serve multiple users, and it is actually a multi-user operating system, and these users are actually connected to the central system via various terminals, and these central systems are often called as server system. So, we can say we have one system which is there, which is we can say designated in order to serve the request, and that particular server system is there to serve a large number of users who are connected to the system, and these large number of users are connected to the system via terminals. So, here you can have a look on the on a particular figure which is giving you a kind of, we can say we have some peripheral devices are there, namely disk, and some input output devices like mouse, keyboard and printer, and also we have monitor. And now see what is happening here. If you can see, the disk is connected to a shared memory via disk controller. Similarly, the devices which are attached on the USB port are having their controller as the USB controller. So in that category we have mouse, keyboard and printer. Now for monitor we have as controller we have the graphics adapter, and we also have CPU. So now what actually happening here is, I have just told you that the disk controller, USB controller, graphics adapter, which is the actual we can say controller for monitor, all these device controllers are attached to CPU are through a common system bus, and they are also able to access the memory through that particular common bus also, and it is given in it is very well shown in the figure. So if you can see here, there is a common bus which is, let's say kind of connecting CPU to graphics adapter, that is also being connected to USB controller, and that is also connecting disk controller, and that particular bus is actually also connected to the memory. So if a disk controller, USB controller or graphics adapter are going to access the data which is stored in the memory, those device controllers are going to access the data through that particular bus only, which is shown here in the form of a line. So this is actually we can say is the architecture of a particular system, of a particular general purpose computer system, in which there could be one or more than one CPUs and a number of device controllers that are connected through a common bus, and that those device controllers are are able to access the shared memory through that common bus only. Now if we talk about the two ways in which the computers can be used, are actually the single user system and the multi-user system. So when we talk about which computers are to be used, so here we have personal computers, and you have your desktops and laptops into that. Then we have some workstations also that fall into that particular category, and here we will be seeing, or here we will be demonstrating that which type of computer generally falls into which system. So when we talk about a single user system, it is generally a desktop which is used by a single user, usually with one processor, one or two hard disk, and only one person using the machine at a time. This is what we call kind of a single user and a multi-user system. So I'll come to the multi-user system as well. So single user system says the personal computers and workstations, they fall into this category. One CPU, typically one processor we can say, maximum one or maximum two hard disks, and one user which is using machine at a time. On the other hand, when we talk about a multi-user system, the multi-user system is having more disks, more number of disks, more memory, and kind of we can say generally have multiple processors, and it is going to serve a large number of users who are connected to the system remotely. Here in a single user system, the device controllers or various devices have been served through a common shared bus we can say, while in a multi-user, in a typical multi-user, it is going to serve a large number of users, and these large number of users are connected to the system remotely we can say. Now this is what we talk about at actually the hardware part of this single user and multi-user systems, and how typically we can say how they are designed, for how they look like in terms of their physical structure, or how they are in terms of their physical structure. But when we talk about the facilities which are given by the single user system and the multi-user databases, there is going to be a sea of differences between the two, because the single user usually do not provide many of the facilities they are which are provided by a multi-user database system. So for example, which particular we can say facility I am talking about here is, let's take the example of concurrency control. So concurrency control is, if you can see, it is generally not required when a single user is generating the updates only. So in this situation of the single user, your concurrency control is actually not required, or we can say required in a minimal amount. Coming to the provisions for crash recovery. So provisions for crash recovery are actually kind of, we can say, are either not present, or if present at a very primitive stage. For example, one of the procedures of crash recovery is just making a backup of the database before any update. So whenever your database is going to have an update, just take a backup of that particular snapshot of database. That could be one of the provisions for the cache recovery. So very limited provisions of these type of recoveries are going to be kind of held in your single user system, while in the multi-user systems, if I am talking about, because many of the users are accessing the database at one particular point of time, so then in that situation there are more chances of, we can say, having end up in a mess through which wherever we need this, so as a result of which we need some crash recovery. So more chances of crash are going to happen in your multi-user system as compared to the single user system, because of the obvious reasons, we can say. And so is the provisions of crash recovery, which are required more in your multi-user system as compared to the single users one. So in this lecture, what we have started with is what actually database system architecture, how these database system architectures are going to give the rise to the necessary structure because of networking, because of distribution, or because of parallelism. And then we have seen the list of 5 types of database system architecture, and within that system architecture we have seen the centralized system, and within this centralized system we have seen the facilities which are provided, or the structure of the single user system, as well as the structure of the multi-user system we have gone through. Here is a list of references which is being used for the preparation of lecture. Hope you have enjoyed one. In the next lecture, I will continue with the various other database system architectures which are left in the list, and we will see them in the detail. Till then, take care. Goodbye.